Hey guys, welcome back. Here we are right now with the past papers practice for the topic of lab apparatus and paper chromatography, and we will discuss some separation techniques in this lecture today, inshallah. So, this is the question number one in front of you. A student determines the concentration of aqueous potassium manganate 7, KMnO4. So what is KMnO4? Potassium manganate. So from now onward, you people should take care of the formulas as well by titration with a solution of ethanedioic acid H2C2O4. All right. An aqueous solution was there. So now, now there is an equation. What is an equation? It is a representation of a chemical reaction. We can say symbolic representation of a chemical reaction is called chemical equation. So there are two parts in a chemical equation. One is before arrow and the other is after arrow. The ones which are before arrow are called reactants and the ones which are after arrow are called products. Okay. Right now, they are asking diagrams of some of the pieces of apparatus the students uses are shown. Okay. So before moving ahead towards the question solution, I would like to inform you that right now at this current stage, when you people have just finished few of the topics with me, I will tell you very clearly that we have not taught you anything related to KMnO4 or the reaction between KMnO4 and H2C2O4 and what is the category of the reaction and what is happening in the reaction. This is not your concern right now. Here we are dealing with the apparatus, particularly when we are going to discuss those chapters, then definitely we will solve those past papers as well. So name the three pieces of apparatus. It is A, it is called burette, and it is B, which is called pipette, and C, which is called conical flask. So I'm writing the names here again. A is called burette, whereas B is called pipette, and the C is called conical flask. These three are the apparatuses which are particularly used in a titration reaction. Titration is basically a chemical reaction between two partners. What is the detail of titration that we will discuss inshallah. But right now I am just telling you that these three are the apparatuses which we are using in every titration reaction. Okay. So examiner has mentioned the word of titration here very clearly. Okay. After this question, I would like to inform you that look at the marks. It is very clearly written three. So you have to write all the three apparatuses names very clearly. Okay. Now, what is the next question? It is a student has to measure 28.2 centimeter cube of aqueous sodium bromide. What is the formula of sodium bromide? First of all, I am writing the formula. It is NaBr. Okay. N should be capital, A small, B should be capital, R small. Sometimes the students are asking, is that very important to write the formula in a very particular way? Yes, it is very important to write down the formula in a proper way. If we will write N capital, A capital, it will simply make this formula a wrong formula. Okay, so be aware of this fact. Which piece of apparatus should the student select? So 28.2 centimeter cube, it is a very exact type of value. It means it is not 50 centimeter cube. It is not very round of figure type of thing. It is not a whole number. It is a points figure. So what we can say right now, 28.2, the particular apparatus which we are going to use for this can be B. Okay. It cannot be A. Why? A is a beaker which is used for the rough measurement of the liquid because it has a wider column. Wider is the column, rough is the measurement, narrow is the column, appropriate is the measurement, more accurate is the measurement. So we can use B for this. Why it is so? Because B has a top value 0, whereas at the bottom near the tap it is 50. So it is 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, and then move, and then finally it is 1, then 1.1, 1.2, 1.3, etc. So it is giving a very accurate type of measurement. Which property of a liquid ester, okay, something can be used to check the purity? our focus should be on the word of purity before use as a food flavoring. It is called its boiling point. Why it is so? Because I have taught you boiling point, melting point are the purity checking technique. So a pure substance will have a fixed melting point and a fixed boiling point as well. Okay. So A will be the answer for the purity. Okay. Then the diagram shows four pieces of apparatus that are used to measure the volume of a gas or a liquid. Okay, which pieces of apparatus should always be filled to the same level? Okay, please look into the question very carefully and find out the key word which is leading you towards the right answer. So they are asking same level. It has lots of measurements in it. You can see in burette. It has also lots of measurements in B, that is called gas syringe. And this C, which is called a measuring cylinder, has also lots of measuring points. But in case of D, only one measuring point, and that is this. Okay. Above the bulb. So this point, the center of the pipette is called the bulb, whereas above the bulb there is one point very clearly. So a pipette will be always filled to the same this level. Okay. So now there is another question. Three gases A, B, and C have the properties shown in the table. So A is more denser than air. Okay, A is more denser than air, and it is soluble in water as well. So it means that A cannot be collected through Z. So A should move down as it is denser than air. So what we can say, so for A, I believe it is X. Why? Because X the gas is coming downward as it is heavier. So we can say that A cannot be collected through water. Why it is so? A cannot be collected through Z method. Why it is so? Because A is a soluble gas, and hence if we will collect A through water, it will just dissolve some of the water, will dissolve some of the gas in it. As a result, the gas will be wasted. Okay. So gas A will be collected through this method called X. Okay, X will be the apparatus. Then what is the next? Gas B. Gas B, they are writing it is less denser and it is soluble as well. Less denser and soluble. So as B is soluble as well, so B cannot be collected through this method of Z. So B will be collected by Y. Why it is so? Because B is lighter, B is less denser as compared to air, so B will move upward. B will move upward. So that's why B will be collected through apparatus Y. Now we can see the next point, and that is gas C can be collected. Look at gas C. Gas C can be collected by using apparatus Z. State why apparatus Z is more suitable than apparatus Y to collect gas C. Okay. Gas C is comparing Y and Z. Okay. So they are saying that it is more denser and it is insoluble. Okay. So what we can say that as it is more denser, so it will not move upward. Okay. So what you have to write for B.1, I am just lowering down the size of writing. Okay, so that my handwriting can be fitted into this line. Okay, what we are saying here, C is denser than air. C is insoluble. So Z is more suitable. All right. Now it is B part 2. State why apparatus Z is more suitable than apparatus X to collect C. Okay. So here they are saying very, very clearly, they are now comparing Z and X. Okay. So for C, X is the apparatus which is for the gas which is heavier. So why it is why they are saying that Z is more suitable as compared to X even. So what is the answer? As C is insoluble gas, so can be collected through Z. So what is the answer? As gas C is insoluble in water, so that's why it can be collected through, it can be collected through what? It can be collected through method Z. It can be collected through apparatus Z. Is that okay right now? So this is how we are going to handle these 4 marks. On the next page, there is another question. You can see, okay, this question is related to chromatography. A molecule contains 4 amino acid units. These amino acid units are linked in the same way as in a protein. Okay. A sample of this molecule is hydrolyzed. Hydrolyzed is a process in which a protein is break up. Hydrolyzed is a term in which a compound is broken up into its components by the addition of water. So, for example, if we have added water to a compound and that compound is breaking up into its components, then that process is called as hydrolysis. So, amino acids or amino acids, both the terminologies are correct. So, amino acids are combining with each other, are attaching with each other to give you the protein. Protein is a building structure of our body. So, what is happening? When we are going to hydrolyze a protein, it is going to break up into its components, which are called amino acids. Okay. Now, we will teach you protein by the end of the syllabus, near the end of the syllabus, called as the topic will be polymer, inshallah. But right now, I'm just telling you that the word hydrolyze is telling you that we are going to break up this protein. Okay, what's written here? A sample of this molecule is hydrolyzed, the resulting colorless solution. They are pointing it out very clearly. Colorless solution is spotted onto chromatography paper, which is called chromatogram. The paper is placed into a suitable solvent. A diagram of the final chromatogram is shown. Okay, done. Okay, now we can see the initial line. So that's why the initial line is drawn in pencil and not in ink. So the same thing which we have done in the previous video. What is the answer? As ink of the pen will be dissolved into the solvent and hence will affect the results. Guys, can you look at these 2 lines? So be careful how to use these 2 lines carefully. What is the answer? I'm explaining it again. As ink of the pen will be dissolved into the solvent, hence will affect the result. Okay, draw a line on the diagram of the chromatogram to show the depth of the solvent into which the paper is placed. So here is the line, very clear line to tell you till this level the paper will be immersed into the solvent. This is the line, this is the depth point till which the paper will be immersed into the solvent, and that line is called as the depth of the solvent. Remember this thing, that this line should be below the start line. Here I'm mentioning it again. This point is that the top point is called as the start line or the baseline. It is called the baseline. Okay, whereas the position of solvent front is there, the top line. Okay, suggest how the chromatogram needs to be treated to make the spots visible. Look at the top, they have mentioned this thing very clearly, that the spots are colorless. So there is a substance, there is a chemical called lucating agent, a reagent, it is called as lucating agent. Okay, so what is this term reagent tells you? Okay, reagent is any chemical. Okay, so lucating agent is basically a chemical. So a chemical which is reacting with the colorless spots to change it into a colored compound. Simple. Okay, so lucating agent. So how the chromatography needs to be treated to make the spots visible? Lucating agent only is not the answer. What you will write, lucating agent is sprayed, comma, it will shift the colorless spots into colored spots. Very clearly what you have used and what it has done. What effect does hydrolysis have on the sample of molecule? currently this is not part of your syllabus, but it will be taught to you when we will teach you the topic of polymer, inshallah. Right now, I'm just telling it to you that when a hydrolysis is happening to the molecule, as a result, the molecule will break up into its components. Suggest a reason why only three spots are detected on the final chromatogram, as the two spots have the same RF value. Okay, two of the spots have taken the same position. Two of the spots are superimposed over each other. Okay, they are traveling the same distance on the chromatogram. You people may say this thing as out of four, two spots have traveled the same distance. That's why they are superimposing each other. Okay, so this is how we are going to solve the past papers. These papers are telling you the way, the technique to solve the right approach of the past papers. Okay. Thank you very much, guys. Take care of yourselves. See you in the next class with the past papers practice.